Hi, today we're going to talk about section 2.1. So we're in chapter 2, and we're going to talk about section 1, which is all about functions. So first of all, what is the definition of a function? And a function, and a lot of times we give these functions names. We like to use letters. One of the most common letters for a function is the letter F, G, H, whatever name you want to give it. And it is a rule, usually a formula of some sort, that assigns to each value sometimes referred to as an element, each element. And we like to let some variable represent that element. So we're going to let the letter X represent that element in a set A. Exactly one element which we will call f of x in a set B. The set A that we have referred to up here, the set A, so the set of inputs, the stuff we put into this function, is referred to as the domain. So the set of inputs. The range is going to be the set of outputs. Set of outputs. Okay. If you're thinking set builder notation, it's the set of all f of x's such that x is an element of A. So there's some notation for you, kind of starting to step up a little bit in your math skills. So this is the set of all f of x's. So f of x just represents a number, a symbol, a something that is the output of some sort of value, some x, that was in some set A. So let's look at a picture to kind of to illustrate what's going on. Let's say I have a set A, and it has some stuff in here. Okay, so it's got 4 little things in here. This function takes every single one of them to something in B. So here's our set B. So F is the way that it goes from here to here. Now some of these could all go to the same point. There's nothing that says we can't take a bunch of pieces to the same point. But everything in here, so we can't leave anybody left out, has to go somewhere. So this is an illustration of a function. Now there might be other stuff in B that doesn't get used, and that is also okay. Some things that cannot happen is we cannot take one item to 2 different places. So this would be not considered a function. So here would be our B. Okay, because for everything in here, it takes and maps it to one specific item, exactly one. All right, and it also says to each value. So we also can't have something like this going on, where this goes to something, this goes to something. So here's A and here's B. But this guy's left out. We have to make sure that everything in our domain gets mapped over. Sometimes we can avoid this by redefining what our domain is, and we'll talk more about domain later in this section. So hopefully this gives you an illustration of what a function is. I like to think of it as a function as a proper operating vending machine. You go to a vending machine, you see all the options, you push a button. Pushing a certain button causes one of those things to drop down. Now there may be a couple spots in that machine that have the same item. So maybe there's 2 spots because Snicker bars are common. There's 2 Snicker bars in there. So there's 2 ways, 2 things that are getting mapped to Snicker bars, or maybe 3. You know, who knows? But a machine does not, you hit a button and 2 things fall out. So that would be not a function. So in other words, the machine isn't working properly if you push one button and 2 of those things come down. So that's kind of what a function is. We see functions in mathematics a lot of times in terms of formulas. So let's look at a function. So here's a function. So f is the name of the function. It works on a variable. And what it's going to do to that function is it's going to take that variable, square it, multiply it by 3, and then subtract 2. So this is the rule on how we take a value and we map it to something else. When we look at something and we want to calculate what is f of 3, that simply means we want our variable or our item that we're mapping to be the number 3. So to calculate what f of 3 looks like, we simply substitute 3 into that expression for our variable. So we'll take 3, square it, which gives us 9. Multiplied by 3 is 27. Subtracting 2 is 25. We can calculate f of a -1. And this is read f of -1. So it's not multiplication going on here. We don't have multiplying. This is the name of the function. This is what it is acting on. So f of -1 is to take and substitute that -1 in for that x. That's our variable's value. -1 squared is 1 times 3 is 3 minus 2 gives me 1. We do not have to have numbers for our variable. For that, we could actually calculate what is f of a. Well, f of a is going to be the same thing as if x were a. So we're going to substitute a into our rule wherever we see that x. So it turns into something that looks like this. I could do something that looks like, what is f of h? Again, we're going to replace our variable with its new representation called h. We can have really complicated things that we're substituting in there, namely a plus h, which means instead of x, I have this ugly mess. But again, instead of x, we're going to replace that with a plus h. And then we can simplify this. So we could multiply that out. So I'm going to remember that a plus h squared is a plus h times a plus h. So that gives me a squared plus ah plus plus h squared, which then turns into, let's slide this up here, 3a squared plus, and there's 2 of these, so I'll write this as 2ah here. So that's going to give me 6ah plus 3h squared minus 2. A very common expression that is seen in calculus classes, so when you get into your next class, hopefully that is calculus somewhere, we will see this expression, f of a plus h minus f of a all over h. So a lot of times this is an expression from calculus that we need to work with. So I'm going to abbreviate calculus. And again, I've mentioned this in other videos, that a lot of times it isn't the calculus that makes the calculus hard. It is the algebra. So here comes the algebra. So this is the expression that we see in calculus. But we need to simplify this. So if this was my function, the one we're still working with, f of a plus h, well, we just calculated that. That was this 3a squared plus 6ah plus 3h squared minus 2. That was this piece. So this was our f of a plus h. Simplified down, which we had done before. Then we want to subtract f of a. Well, f of a we also did. That was up here. So we're going to subtract 3a squared minus 2. And then we want to take that whole thing and divide by h. Calculus will tell us why we want to do this, but now comes the algebra. And this is what hangs students up, is just cleaning this up. Well, first of all, understanding what this represents and kind of making sure you know what f of a plus h looks like. F of a plus h means take f, substitute in that a plus h for whatever variable we're working with, then subtract f of a, take all of that and divide by h. So here's my f of a plus h multiplied out and so forth. I'm going to subtract f of a, so I'm going to kind of rewrite and do some algebra here. So I'm going to distribute that negative through. You'll notice that our 3a squared and that negative 3a squared disappear. My negative 2 and my positive 2 disappear. All I have left is 6ah plus 3h squared. Everything else is gone. That's gone with that. That one's gone with this one. And that's going to be divided by h. Now notice there's an h in both of these. And that's the nice thing when we see these problems. The h that's down in this bottom will cancel with something. And it should reduce out. And we end up with 6a plus 3h. And then would come another little bit of calculus, but the calculus that we're going to do is let h be 0, and we'd be left with 6a. But it's not, again, the calculus that causes us issues when we get in our calculus classes. It's all this algebra, this simplifying. So again, the little baby steps matter. Write the little steps out. Make sure we understand. I want to do one more, and then I'm going to stop this video so that I can switch to another topic. But let's look at a new function. Let's call it g of x. And I want to have 1 over x plus 3. And we are going to do this g of, I'll do x plus h minus g of x all over h. Now there's no reason why I had to have an a instead of an x, but again the same properties fall through. So we're going to look at our function, but instead of just x, wherever I see an x, we want to replace that with g of the x plus h. So we're going to look at that g of x plus h. That will look like 1 over x plus h plus my 3. So instead of my x, we have that x plus h. Then we're going to subtract g of x, which is 1 over x plus 3. All of that divided by h. Okay, now comes the algebra. And again, this is why we kind of reminded ourselves of these complex rational fractions. What do? I need to get a common denominator. The common denominator is going to be this whole term and that whole term. So my common denominator will be that x plus h plus 3 times that x plus 3. My new numerator on the first one will be that x plus 3. And then we'll be subtracting. The new numerator here will be this piece, x plus h plus 3. And that's still all over h. I'm going to subtract. So that's going to give me x plus 3 minus x minus h minus 3 all over my common denominator. All over h. So all I've done is distributed the negative through. You'll notice that those x's are gone, the 3's are gone, and we're just left with a negative h over that common denominator, which we are going to divide by h. So we're dividing by h, which means we're going to multiply by 1 over h. Notice the h's cancel, and I'm left with a negative 1 over this x plus h plus 3, x plus 3. And again, in a calculus class, we would have a little bit left to do, but for now, we're just going to practice that algebra that gets us there. Okay, I'm going to continue 2.1 in another video. I don't like to get these videos too long because I want you to be able to take a break and breathe a little bit and go back to something if you need to before continuing on. Sometimes we need to refresh, need to take a break, need to think about things before we keep going.